Hey, I'm Jeremy Blum.
And I'm Matt Newberg.
And we're just going to do a quick demo of our final project for EC3140 at Cornell, our embedded systems course. So for our final project we used the MSP430 and its wireless transmitters that came on the demo system to make a wireless weather station. So this is one of our MSP430s here with a battery pack for it, and we have it wired up to a light sensor, a simple photoresistor, and a humidity sensor. And those are being powered off of a separate 9-volt battery, primarily because the humidity sensor needs to be run at 5 volts and the MSP430 operates at 3 volts. So we're using a 9-volt to 5-volt regulator to power the humidity sensor, as well as the photoresistor, since I just put on the same board. And then we're using some voltage dividers on here to get the resistors, to get the voltages down to the right level to be read by the analog inputs on the MSP430. And then the radio transceiver on here transmits the data over to another MSP430 that we have that you can just plug into a laptop. The green LED just blinks periodically to show that it's operating, and then the red one blinks every time it receives a message from the wireless weather station. So then on the computer we have some software running. For the main part of our project, all we had to do was basically get the values off, and you can see them streaming through on the serial input there. There's 9 digits in total, 3 digits for each of the sensors. The first 3 are the light value from 0 to 100. The second 3 are the humidity value from 0 to 100%. And then the last 3 digits are a temperature value that we decided to transmit in Kelvin so that we can ensure that it was always positive, and then we convert it to Celsius on the computer end. For the extra credit portion of the project, we made a graphical readout that takes that data and makes it pretty. So this is written in a programming language called processing, and basically we have the light, humidity, and temperature data come in. You can see it displayed on that board there in percentages in degrees Celsius. We do the conversion to degrees Celsius, and then there's an overlaid line graph that shows the values for each one and how they modulate with time.
So now we're going to demonstrate the light sensor. It's right here on the board, and we have a wonderfully bright day outside. So it's pretty easy to just aim this at the light, and we get a drastic increase in the light on the graph there. And then when we aim it back into the room where there's a lot less light, the graph goes down, and you can see it on the graph and the data streaming on the computer. So now it's time to demonstrate the temperature and humidity sensors, and we'll do that by using the heat gun of science. Now, what happens is the heat gun will blow hot air on the temperature and humidity sensors, and that will make the temperature rise as well as make the humidity drop. Now, the relative humidity right now is around 28 or 30%, and the temperature is around 19 degrees Celsius. But then when we turn the heat gun on and we aim it at our setup here, you can see that the temperature starts to rise and the humidity is dropping. So if we keep this aimed at it long enough, we get to dangerous operating temperatures, and I should remove this. So, and then in a few seconds we'll see that the temperature will start to drop back down to room temperature, and the humidity will slowly start to rise back to where it was before.
Now we're going to do a quick wireless range test of the weather station, so I'll walk down the hallway and we'll basically see when it stops receiving data on the computer end. And as I go, you'll be able to see the light values changing as I walk down the hallway and stuff.
When he hits the end of the hallway there, it stops transmitting data. And that's pretty much the range of the sensor, but as you can see, it's still a pretty good distance. And as you can see, whenever he passes underneath a light, there is a spike in the light sensor. So there's a bunch of lights along the hallway. Whenever he passes underneath one, we get a very nice periodic oscillation. Shows that our light sensor is
doing some work. Temperature and humidity are remaining approximately constant.